Raymond, we good? All right. I had specific instructions from Raymond to get started. So welcome everybody to the second Technology and Innovation Rounds. We're thrilled about the session today, and we have folks online as well. We're going to make this as interactive as possible, and because it's a bit of a dialogue, when you ask your question, if you have a question, we'll just ask that you wait for a second. The team will come and bring a mic to you, and then we'll do that. So today we're going to actually do something a little bit different, which is we have the opportunity to really showcase a collaboration, and a very exciting collaboration between eHealth Ontario, and Chris Pendleton and Maureen O'Neill are here, so thank you for coming to this. And IBM, and so we have Bryan Addeman from IBM who's going to be with us, and then our own project team, and Selina and David are going to talk a little bit about the work. So what is the work that we're going to do, talk about in the next little while? So this is about our blockchain and patient control of data. Julie was telling us on the walk over that she was trying to figure out what blockchain was, and David had given her a book, so she was reading through that. And Jeff said that no worries, he's got a YouTube video. So at the end of all of this, if you can't figure out what we're talking about, just talk to Jeff. Jeff's got a YouTube video, he'll sort us all out. But I think the point is that a lot of us have been talking about what is this thing called blockchain and what can it do to help us. And it's fascinating to see how quickly we've really had an amazing dialogue on all of this. And most importantly, we've had patients involved in this. And so Mike Reed is here today to give his perspective on this, and he's our patient advisor. He says he likes that role, patient advisor. He's going to explain to us what that means. And so together we're going to have this little bit of a conversation around what might this technology do to help us reimagine what patient control of data looks like. And what has been our journey so far. It's been an interesting journey, and we'll share a little bit about that. And where might we take this, and where will this go? So the format for today, Selina and Bryan are going to come up and do a little demo. We actually demoed this for the first time a month ago at the Blockchain Revolution Group conference in Toronto. There were about 1,000 people attending that conference. We were fortunate enough to work as a team. We won an award for the great work, and so we thought, hey, we're going to show that here and showcase some of that. So they're going to showcase the demo, talk a little bit about the background, and then I'm going to ask the panel to come up and reflect on what the journey that we've gone on and what we've created means to them. So that's what we're going to do for the next little while. Everybody good? Okay. Is it me, or is it really hot in here? It's hot in here. Okay, so I'm not just melting, because I don't usually melt when I talk. Okay, so Bryan and Selina, why don't you come on up, and hopefully it's not too hot.
Thank you, David. As many of you probably know, over the past couple of years, UHN has enabled our patients here with access to their own health information and health data through the My UHN patient portal. And as of this morning, we actually reached over 80,000 patients who are accessing their information. Yeah. And what we have actually seen is that we have made a significant difference in the way we provide care here at UHN. Patients are reporting that they feel better informed about their care. They're better able to make decisions, and this is helping to help them navigate through their care as well. Okay. But unfortunately, as you all know, our health system and our health data lives in silos. And this is for many different reasons. More recently, over the past year, we at UHN have been working very closely with government to try to look at how we can give patients access to their data, and specifically to the provincial data repositories and the Ontario lab information systems. What you just saw scrolling was, I believe, 7 pages of workflow and process. So you can see that it has been quite onerous in terms of trying to get data to our patients. And with the best intentions, you know, we've been doing this for a little while. We've actually created unintentional encryption because we've made it so difficult to get access. So in more recent times, we've actually been collaborating very closely with our patients, their family members, caregivers, and also with other care providers, researchers, and subject matter experts. So we've been really talking about how and you know, what this fragmented data means to them. It's causing barriers, and we also moved into discussions about how patient control could actually help improve safety and efficiencies for care and research. And we're going to show you in a little while what we mean by patient control. So what our patients have been telling us is that they want visibility and transparency into all of their health data wherever it lives. So whether that means public sector, private sector, their data lives everywhere. And we want to break down these silos. At the same time, patients want the choice of how they're going to view their data. And over time, I think you've probably seen in the media, there's actually been a loss of trust, especially with third parties who potentially might be accessing patient data, perhaps selling or profiting from the data. So patients want to make sure that whoever has access are actually authorized and trusted. And in today's world, unfortunately, it's our health information custodians that currently control access, even for patients. And that's where I think there's a pent-up demand now for patients to actually want to take control. And whatever solutions we look at, definitely we need to make sure that they are private and secure. So we started then digging a little bit deeper into 2 opportunities. One is in the area for health information exchange, and we want to make sure that for patients and care teams that we are looking at one source of truth and that it is accurate and up to date, okay? And that's for the purpose of care. And at the same time, patients do want more granular control into what patient or what other parties are accessing and who is accessing it. And then we also talked about a second opportunity. We actually have missed opportunities right now to connect researchers together with patients. And what patients don't always realize is that there are research and clinical trials happening that could actually help to improve their quality of health and their quality of life. And right now, I think what I've heard recently is that 80% of research studies actually run into recruitment problems. And that's because researchers are relying on clinicians to tell them about the studies and actually help them to enroll into these studies. So we're really missing a lot of opportunities to improve and innovate care for patients. Okay. So we're going to show you how we're now accelerating the future. I'm going to pass the floor over to Bryan.
In a couple minutes here, I'll demo what we created as part of the work that we did together, which is a new framework for sharing medical information. But before I do that, I'll go over a couple of foundational things about what this system needed to do if we were going to create it, why we chose blockchain, and then a quick overview about what blockchain is, because there's a lot of different perceptions about it that are in the media. Some are true, and some aren't specific to the type of technology that we often use in enterprises. So first off, if we were going to create this system, what are the main requirements that we need to be able to cover off? Well, number one, we needed a system that equipped patients with visibility and control over their own health information. We've heard over and over that privacy is really consent plus security. It's not about keeping data secret, it's about having control over your data. So equipping patients with the ability to control it was number one. We wanted to be able to enable sharing of medical information with other parties of whoever that you may choose. We wanted to track the usage of that information by parties who do have access to it and have been granted consent. And then finally, we wanted to unlock access to patient data for the purposes of medical trials, especially from the research perspective. A quick blockchain 101 about what the technology is. Of importance, there are many different blockchain technologies that are out there. A number of them do different things. What most people hear about in the media is Bitcoin and cryptocurrency. That is a fundamentally different type of blockchain. Overall, for all technologies, all blockchains aim to create an irrefutable proof that transactions have happened between different parties. So what the essentials to a blockchain are that, number one, there's a shared record between a number of different parties that are doing transactions today. And if you look at the diagram down on the bottom left, this may represent a standard business network. You're doing business, you're doing transactions with other people within the ecosystem. Traditionally, each one of these components, each one of the corners, they typically have their own legacy systems where they store their data. And if it is health information, often there's their own security policies. There is often also own consent thing. Who has access to what pieces of information? Each entity has their own version of this. What blockchain really proposes is the ability to have one shared record between all of those entities that's always up to date and verified and transparent as to when things were added in there. The second component for blockchain is the idea of smart contracts. So these are you may have heard the term in the media, but at its base, these are the rules that govern how you can put information into that blockchain network, into that shared ledger, or how you can read information from it. One of the key things to note is this is possible to do permissioned. So you can define who within the network is allowed to access which types of information. This is absolutely critical for privacy. The third one is cryptography, and there's a lot of technical components that go into cryptography. Blockchain is, as it says, a chain of different blocks of transaction throughout the network. I won't go into that component of it today, but that's where the name blockchain comes from. What this all entails is really four things that make blockchain very strong for this type of application. Number one, there's one trusted source of patient consent across an ecosystem. It's the exact same version of that consent at each one of those entities all the way around, and it's updated. They all host a copy of that exact same information, so there aren't differing copies of the same thing. Number two, it's auditable, and it's a immutable record of all transactions. Once a transaction is put into blockchain, it cannot be changed, it cannot be removed. You can make additional transactions to change that information, but once it's there, you cannot delete it. So it adds to the trust that nobody can tamper with information after the fact, and there's some transparency as to who put that information on the chain at what time. Number three, privacy rules can be enforced by rules that are coded into the network. So these are components that cannot be changed by one party to unilaterally make some extra benefit to them. One of these companies that is in the network cannot change the smart contracts themselves to benefit them. It's a network thing that needs to be changed by the governance board who runs that network. And then finally, there's potential further automation for smart contracts. Smart contracts are just business logic that are put into code. If there is some business logic that you can define, you can code that into a smart contract, and you can start to automate processes that you could code. So there's a lot of opportunity to automate processes and potential back-end works like accounts payable and a number of things as well. Of note, there's a lot of talk in the media that is really dominated by cryptocurrencies. And I wanted to overview that there's two fundamental types of blockchain networks that are out there today. On the left side, you'll see a public permissionless network. A public network meaning that anybody can come in and join that network and run transactions on it. There's no restrictions. Permissionless being there's no direct permissions that indicate what that person can do with the network. They're allowed to make any transactions that are allowed in the network. So this is what Bitcoin is, and Ethereum and many of the other cryptocurrencies that you've heard that are out there today. We work with a fundamentally different type of technology, and it's an open source technology called Hyperledger Fabric, and it is a private permission network. Private meaning that only companies who are invited to participate in that network are able to participate. And then secondly, it's permissioned. So there are rules that you can associate with those members of the network, which information they can see, which types of transactions that they can do, and you can apply those autonomously within the network. So there's four main differences that I've noted between them because they go with a lot of things that we hear in the media that aren't necessarily true for private permission networks. Number one, it involves a cryptocurrency. That is true for Bitcoin. It is not true for Hyperledger. We do not use a cryptocurrency as part of our networks. It is not required, and I'm happy to go into why later, but I won't get into it today. Number two, all data is public. That is true in public networks. That is not true in private permission networks. Part of that permissions is defining who's allowed to see what data. Incredibly important, especially when there's competitors who don't want to be able to see the other person's transaction info. I suppose they would, but it's very important for companies to join to not disclose that information where necessary. Number three, high electricity usage. We've heard that Bitcoin takes the amount of electricity to run the network as Finland uses in a day. That is only true for public permission networks. It is not different in private, or it is not the case in private permission networks. It's pretty trivial. We use about the same amount of electricity as running a regular application. And then finally, transaction scalability. There's been a lot of issues with Bitcoin scaling to the number of transactions that need to happen. We use an indicator or a measure in transactions per second. Bitcoin can currently do 8 transactions per second. Hyperledger Fabric can do up to 10,000 transactions per second, and it was 4,000 last year. The technology continues to get better and better. Why does this matter? There are, at the scale of a production network, we need to be able to run a large amount of transactions. To compare this with what's out there, Visa runs on the order of about 50,000 transactions per second at peak demand. So while we're not there yet for a Visa type use case, it's quickly getting there, and I would anticipate over the next couple of years, this technology would be able to handle that. Finally, the last one of the knocks on blockchain is that we haven't seen production networks out there being used. And sometimes they're hidden in plain sight. There's 3 networks up on the top right that are absolutely massive. TradeLens is for global shipping. It was started by Maersk. There are now 500 million cargo shipments that have been captured on that blockchain network. There's over 100 entities across the globe that are part of it. Canada Border Services Agency, Port of Halifax, Port of Montreal, CN Rail are all a part of this network. There was a large announcement this week that 2 other global shipping companies have joined in combination with Maersk. So they now represent over 50% of all global shipments that are going to be run through that network. Absolutely massive. Food Trust, which is for food traceability. Walmart recently announced last September that all of their suppliers of leafy greens will be required to use this network. We've been waiting for a while to see one major retailer make that push and mandate it that all their suppliers are going to have to do that. That happened last September, and they were required to use it by this September for all leafy greens. And then finally, a recent announcement from Canada, which was SecureKey in combination with the big 5 banks and a couple other large organizations in Canada have launched this for identity. Highly, highly private information being shared on blockchain. These are all using the same technology, Hyperledger Fabric, on the right, and that's what we're going to be showing today. Okay, so why blockchain? Well, number one, our health system is decentralized itself. Our health information lives in a number of different places, and I talked about the different legacy systems at each of those locations, different versions of consent. This is a system where decentralized consent is needed. We need the same version of that consent to help unlock information across the ecosystem. Number two, patient privacy and security is paramount. Blockchain has some unique applications where you can apply very interesting privacy controls within the code itself. Very well suited for this type of application. We can enforce those privacy rules that are required in the network. With that transparent ledger of all transactions, we can add transparency to this. We can show patients exactly what's happening to their medical record when transactions happen. We can actually show that to them, and it's always there. And then finally, part of that being able to change around these smart contracts allows us to have future innovations in consent. What we'll show today is a binary version of consent. I'm going to share all of my information or none of my information, but this system allows you to code anything that you would like. So if you would like to do I only want to share my psychiatric information, that's all possible within the ability with this technology. Okay. I'm going to go a quick overview about what the broader vision of what we're trying to achieve with this application is, and then talk about what we built as part of this minimum viable product. I'll call your attention to 3 different sections on this slide. The first one up top in the blue band are all the different applications across the ecosystem that have a requirement to get medical information. So we have patient apps, care providers, which may be an electronic medical record, pharmacy, researchers, where they may have an application to do study recruitment. And then at the bottom, we have all the data sources that exist out there. These are all the data silos that are there today, which contain medical information. What we've created in this project is a blockchain consent gateway in between, which both helps define the rules by which how you can access information and enforce those privacy rules across the ecosystem. And there's a couple things highlighted up there. There's a consent application for a patient app and a research application for study recruitment. That's what we've built as part of this minimum viable product. We aren't able to build this entire ecosystem initially, so we started with 2 small concepts that we could prove out the concept. So what's happening at that blockchain consent gateway is there's one shared record of a patient's consent. So when anybody wants to request information, we're going to that gateway, which is acting like a traffic cop and saying, yes, you either do have consent to access that information, and then helping them route that request to the right place down below to get that information out. And as part of the work that we did in this project, we've created a minimum viable product, which has these 2 applications. So up top, you'll see a patient consent application and a researcher application. We'll be demoing this in a moment. And we wanted to prove that you can get 2 different sources of medical information that are in different entities. And we used, number 1, the laboratory database from OLIS in the provincial health system, and a secondary source in a care provider system, and in this case was UHN discharge summaries. So what we're going to see in the app is the patient being able to consent to what they're allowing to share, and then that blockchain consent gateway enforcing those rules and allowing you to access information from it.
So I'd like to introduce you to Sue Pierce. She is a patient here at UHN receiving specialty care, but she lives in Peterborough, Ontario. She has 2 children and travels once a year with her good friend. Her husband had passed away several years ago, and she is being treated for cardiovascular disease. She had some surgery done a number of years ago. Okay. So what I'm going to do now is I'm actually going to give control over to Susan to control her health data. Okay. So what you're going to see is that I'm going to log in here. So Sue Pierce is going to authenticate into the system. She'll enter her credentials. And again, this is the common gateway that Bryan had just talked about. And immediately, she actually sees the people and organizations that have been authorized or consented who are consented with certain protocols to either access or contribute to her data. So by default, her healthcare providers who give her care already have access to her health information. But earlier this year, Sue actually had given or authorized access to her 2 sons and her good friend Sunny, who had traveled with her on vacation. Just in case of an emergency, she gave Sunny access to specific health information just in case something would happen to her. Okay? But now that they've returned from vacation, Sunny can be removed from the consent list, and you can see that immediately Sunny has lost access to Sue's health data. All right. Now in this app, as Bryan mentioned, we've also, actually before I move there, you can see that, that these transactions were logged on the blockchain. Okay. Now, Sue has also the ability to consent to be contacted by researchers through this app. So in this app, she's going to simply say yes to consent to be contacted. And then, yeah, I'm going to, whoops, pause there. Okay, we'll switch places. Oh, sorry.
That's okay. I'm just going to go back a bit here. Since blockchain is a behind-the-scenes technology, we don't often get to see what's happening. But if you'll notice, we took 2 actions on the patient application before. We removed consent from a family member, and we also opted into research. Those are both transactions that happened on the blockchain network that are captured in behind the scenes and then replicated across the entire network so everybody has that same information. This is a show of the environment that is actually running the blockchain network. And here we see the total number of blocks, and these represent transactions that are happening. Since we've seen 2 transactions that happen, we would expect 2 more blocks to be added to the network, which represent those 2 transactions. So sure enough, after refreshing this, we see the block size go up to 1720, where it was 1718 before. So each of those 2 transactions were shown in the history for that patient. They could see what happens and now are reflected on the network. Now that the patient has been opted into being findable by research, I'm going to shift over to a different role within this, and I'm going to act as a researcher within this network. So I'm a clinical researcher named James Brown, and I am doing cardiac research. So I have my own portal. This is a separate application than what the patient is using, and I have to log in on my own. So I'm logging into the network here. And since this is a demo application, we've made a couple of assumptions beforehand. So you could picture that I'm trying to set up my clinical research study, and I'm looking to recruit patients of a certain type for my research study. This is a cardiac arrest study. I'm looking for people who have had a recent cardiac event and have visited the hospital, and I'm looking for people who have lab reports that have been done. So in this case, that maps to our 2 data sources that we have, a UHN discharge summary and the OLIS reports from the OLIS database. So I'm going to, in real life, you would be setting up the study and what you want to do. In this application, we've already just assumed that we're going to do 1 study and we're going to set this up. And the 2 pieces of information that I'm looking for are lab results down here and the discharge reports. And this is de-identified information. As soon as I click Start Recruitment, this is going to go look in that blockchain network for everybody that matches those criteria and has opted into being findable by research. So they must have consented to that. So as soon as I do that, I'm going to click Start Recruitment here. Skip forward a little bit. Okay. And a new dashboard shows up. So this is after that request has been sent out to everybody else. And right now, you'll notice this is a small demo network, so we only have 1 participant. But that 1 participant is shown down below, and this is completely anonymized. So the researcher does not know the identity of who this is. That is protected by the blockchain network. And the status is that they have requested it, and that happened at this time. So we'll switch back over to Sue Pierce to show what changes on her side and see what happens when she consents to the network.
Okay, whoops. We'll speed it up a little bit here. All right. So on Sue's end, she actually is receiving a notification from this researcher. And she has the ability to look at the details of this research study, find out more about it. It tells Sue how long the study is going to be running for and what data or what information the researcher is requesting. And here, she's going to consent to participate in the research study. Okay.
And if we flip back over to the researcher view, if I go back in here, I can now see that our application has changed. Whereas before we had 0 consented, it changes to 1 person who has consented. I still can't see the identity of that person, but I have proof that they have consented to it. And after that happens, a new feature has shown up, which is this button that allows you to access information. Now, as part of this project, we wanted to show the ability to access but not necessarily download the information. So we likely saw this as being used by some type of medical viewer, But what's happening here is when I click this button, it's actually making those calls to those two different databases, to OLIS and to the UHN discharge summary. And we're just showing the raw data that comes out here, but this is real data from those two sources. So if I scroll through here, you'll see the OLIS report that comes up first, and this is the raw data from that, and then the discharge summary down below from the FHIR server. So this has successfully used the blockchain network to apply the consent directive and then pull that information for the patient without ever disclosing the identity of who that patient was. And let's say for this study, I don't have a need to know the identity, I just need this information. This has created a new way of doing that. And as a quick overview about what is actually happening behind the scenes from a blockchain perspective, this is what the network looks like. We have two different applications that we've shown, one for the patient, one for the researcher. They are connecting into this blockchain network in the middle. And there's 3 different owners of that network. I showed that diagram before of what happens in a blockchain network. There's different organizations that own it. So in this case, we have eHealth having one network, and they're exposing an application to patients through their own role. We have researchers, which is owned by UHN Research, and then finally another one for UHN. So what's happening when that researcher clicks access data? It is sending a request to the network, and it is checking our blockchain application in the middle. And number 1, it's logging that request, so we know who requested it at what time. Number 2, it's cross-referencing it with that patient's consent directive. So if that patient has changed their directive even 5 minutes ago, it will see and look up that directive, and if the patient does not allow it, then this will stop right here. Finally, if the consent does check out, then it will log access to that information and make the call to these 2 data sources and then retrieve the information from there. And every time you access information, this log access is happening. So we're able to see not only that information was accessed, but every time somebody accesses your information, adding much more transparency.
So just in closing then, I hope you can see how patient control of data can actually help to transform the health system. You can see that patient control can help to reduce the fragmented data, the silos of data, and actually help us to find new models to innovate care and research. So I'm going to ask David to come up to the podium. And then
Maybe I'll ask the panelists to take a seat up. So thank you very much. That's a tremendous, good, fantastic work. And Selina, before you lose your phone, we did this the other day and we had to retrieve a phone. So there we go. I just want to call out, we saw the beautiful design work when we were talking about who was involved. Health Human Factors did a beautiful job of designing the app and the interface and has been a really important part of this team. So just wanted to call them out. Okay, so I'm going to jump right in because we don't have a lot of time. And there we have the titles of our folks, so you can see them up there. And I'm going to start with Mike, and if you're okay with that.
Absolutely.
Okay, and so we kind of landed on this phrase of this changes more than everything in terms of what it might mean for patients. And so I'm wondering if you can maybe just reflect on that, whether or not you think that resonates with you, what some of your experience has been, and whether or not you think this will change the way that patients interact with the healthcare system.
I think, as a user of the UHN portal from pretty early days, I think it's a wonderful extension to that functionality in that I think it provides a whole gateway of other potential services. I'm particularly intrigued by the integration with research. I think I've never seen anything like that, and I think it's really groundbreaking that from that building block of the portal to the consent to the research, I think that's super compelling as a patient. It's super compelling as someone who's interested in helping build knowledge and share and sort out a fundamental bottleneck in the process that people want to be helpful, they want to add, they want to contribute, and this is a fantastically easy way for them to get some skin in the game on research. So I think it's fantastic.
Thank you. Chris, maybe I'll put you on the hot seat, and you've been going through this journey with us, and I think Chris has played the role of not only having provincial perspectives on this, but I could maybe say a healthy skeptic on this. And
It's part of my job.
and so maybe you can just reflect a little bit on where you think you're at and where you think we're at and where this might be going in terms of its promise for
problem.
Ontario.
It's definitely still early days, but one of the great things about doing a project like this, I think we spent over a year and a half discussing it, planning it, finding out what the proper use cases to start with. But you never really get into it in depth until you actually try to develop something. You actually do it in a relatively real way. So this has really given us the opportunity to actually figure out the real complexities behind this, and there are a lot. Consent by itself is a pretty complicated subject just by itself, and a lot of institutions are required to obviously apply consent rules, and eHealth Ontario is definitely one of them. I can actually tell you without a word of a lie that we at least use the word consent about 100 times a day. We're discussing it at about 100 times a day. It's that important to us. It's a big part of what we do. So this is giving us an opportunity not only to figure out within the agency what do we do about consent, but to do it at Ontario scale. Because if we just do it to protect the assets that we hold at eHealth Ontario on your behalf, then that's only part of the picture. Because if it's available from somewhere else, then it's not really consent. So the real problem with consent is it's not a per institution problem. It's an Ontario problem, and we need to solve it at that Ontario level. And this project's allowed us to start that discussion in a very meaningful way to start the journey on how to solve that kind of problem.
Thank you, and thank you for your tremendous support in moving this forward, so thank you. David, do you have comments? More than everything, really?
More than everything. We don't know everything. There's always more. Can you hear me? Okay. Yeah, I think this, what gets me most excited about this project is we know that consent is very important. I mean, fundamentally, it's about the individual doing the consent and the engagement of individuals in the management of the data. This is this whole world of sort of a data economy and the participation of individuals in managing their data moving forward. And more we know that that's what people want to do. Whether you're watching it on Facebook or Cambridge Analytics and the issues, people want to have that control. But you think about that, it's extremely complicated. We showed that flow chart about how many things we'd have to do to figure this out, and it's just too complex. And I just get very excited whenever I see technologies that allow us to bury the complexity. And so somehow this very complex thing about how do you manage consent across all these silos, oh my God, we can't figure this out. And you just step in with the new technology and you turn it upside down. And all of a sudden the complexity is buried. All management of the data is through this simple app and lets you do everything from sharing information with your kids or a traveler or a researcher or whoever else. And it's just managed. And all that complexity is buried. And I find that the most interesting part is it suddenly appears to simplify. Yet we know behind the hood, as we heard from Bryan and others, it's complex, but you don't see it. So that's what I find most exciting. Because you see, whenever complexity gets buried, there are periods of rapid innovation after those. And this is just on the verge of very rapid innovation as the ability to handle data ourselves takes off. So it's cool.
It's cool.
It's very cool.
Who has a question? Anybody have questions for our panel, for what you've seen so far, where we're going, what we've done?
I have a question. So if I was a clinical researcher, and say a patient had cancer of the lung, and I was looking for very specific criteria, so say I was looking for maybe a hemoglobin level or maybe a mass over 4 centimeters, would you be able to put those parameters in to get that information?
Well, I think this is the level of granularity we'll have to explore. But one of the things that we tested here is the sort of findability. So one of the elements that's coming out from a data perspective is called the FAIR principles: findable, accessible, interoperable, and reusable. Those are FAIR, F-A-I-R. And if you don't know the data exists, you can't ask for it. So how do you learn that it exists without actually seeing it? So that's the findability paradigm. And so we explored the findability paradigm here with just simply saying, as a research organization, can I reach out to a patient? So the patients had to first declare that I'm findable. In the future, what will happen is the different elements of the data that belong to those patients could also be declared as findable. And then once you find it, you can enter into negotiation for access. But you first have to know that it exists before you can even ask for it. So this is just a glimpse of that findability paradigm starting to become real. And if that's the case, you could be extremely granular on what's shared and findable.
Thank you.
I'll add one thing to that, which is that the technology allows for that right now. And one interesting thing that the FDA did was using this use case for genomics. So they are ingesting all this genomics data from clinical research studies. And what they did was strip away a couple of biomarkers from that genomics data and put it into a searchable database to find afterwards. So they're using blockchain as the underlying mechanism to keep track of everything as it's ingested in and then being able to find it afterwards. So it's a great example of something that has been proved in concept and could be extended to in the future.
Awesome. I saw some other hands. Jeff? Oh.
Just doesn't like my frequency of my voice, I guess. How hard is it to add another database into the mix? Right now you've got OLIS, but what if you want the pharmacy in there so the person can look up which medications they got?
I can take that one. That's part of the work that we're doing right now. The goal of that blockchain gateway layer is to define the privacy rules that protect the data behind each of those sources. So we're working on that, mostly the standards part of it now and how to come up with that framework. And we've thought about it like a data access token. So when you come and request information from the network, we will issue you a token which represents the security policies and what you need to do to be able to get that data. As soon as you get that, now all these different data sources, assuming that they trust this network because they know the rules that are part of it, they can accept this token that's issued by the network. So the token is digitally signed by our blockchain gateway, so they know it's valid. And then when they go redeem that information, there is another connection point to the network because we track every time data is accessed. So we know that nothing has changed within that time. It's a good way of always keeping track of accessibility and then enforcing that through this token idea.
You can easily add additional databases or systems. They could be legacy systems as long as they satisfy the requirements in terms of that interface.
It's actually been designed that way from the get-go. That's why it's a gateway. So basically, we set up a pattern with OLIS in this particular case that can be easily applied to the drug repository or discharge summary repository or whatever else comes in the future. And that's the whole point here, to make it generic enough that we can expand it to not only other institutions, but also within different data sets as well, too.
I just have one more question. It actually comes from Walmart. Your Walmart and the leafy vegetable example. We've heard in the media in the last while about counterfeit medications, pharmaceuticals, also being able to trace back, IV solutions or blood products. Do you know of anybody out there that's actually working on a leafy green vegetable type idea for those at the moment?
There are some that have been worked on behind the scenes. Of most note, the FDA announced a new collaboration and a new set of funding that's going towards building just that. So both KPMG and IBM are involved in that, as well as a number of the big pharmaceutical companies in the US. And they're starting to define how they would build something like that in accordance with the DCSCA Act that they have there. So things are starting. It's going to take some time to get to production, but they're on their way.
In fact, one of the award winners at this blockchain global meeting that we were at is a 15-year-old that is specifically working on better managing drugs in developing nations because there's a lot of fraud. And she got an award for some of her work. Incredibly bright. And I think she's supposed to meet with Selina, or she already has, because she wants
I
to
think
work
she's
with us.
coming back in a couple of weeks.
Yeah.
Right? Yeah.
If I can find out where my lettuce is grown, I should be able to know where my medication is.
Exactly.
Mike, did you want to make a comment?
I had a question. Yeah, I have a question. I'm the patient guy. So I'm a patient of the Family Health Clinic at Toronto Western. But that's a different system than the UHN system. So is there a dependency on vendors to adopt something, to do something to make this work? Because if they're using different systems, I can consent. But if it's siloed, I guess the big question is, how much is breaking down the silo dependent on the vendors?
I mean, I think it does depend on the vendors to adopt the interfaces that we develop. That's
Yeah.
important. But the one thing about the technology, most systems you think about, they have their data at their heart, and then they have controls on accessing the data, and then they have applications. That's how all applications have been built, pretty much. Which means when you want to take that application and interact with another application, you have to somehow get the hearts to connect. Which means you have to go through all the layers of the control of the data and the application usually. So that becomes very difficult for groups to work together. In many ways, blockchain technology lets us take that and flip it outside. So the architecture for control is exposed, which means that's sort of like an exoskeleton instead of a conventional skeleton. And it's much easier for people to tap into that system because now it's public and exposed, or depending on the type of blockchain, as you heard, it's available and exposed. So it actually creates an economy where many different individuals can and organizations can access, because it really took all that control of data and it flips it outside.
To Mike's question, actually, in a couple of weeks, I'll be heading to a conference where I think the majority of the EMR vendors for family physicians will be there. But I think there's also a lot of pressure now from patients, advocacy groups, et cetera, and other groups who are recognizing that a lot of this data is so locked into these vendor products. I think this forces them to come out and think of alternate ways. And of course, for us, we've been working with the fire services, but thinking of how we can start getting more connected. I think there's more pressure on nowadays. Yeah.
Can I ask another question?
Sure.
So
You ask hard questions, but we'll try our best.
that's why I'm the patient advisor.
It's good, it's good.
But it's like, so is the protocol that's going to be established for these EMR systems to talk to the consent system, are they going to be unique to Ontario, global? What sort of level is anticipated?
That's an awesome question. One of the things we have talked about, and one of the things Selina mentioned, was a consortium called HL7 FHIR, FIRE for short. That community has already developed a lot of the messaging standards for consent.
Sure.
And it's just a matter of us, now they're fairly new, so it's a matter of us testing them out with a service like this so that vendors will feel comfortable in not having to do something proprietary. We ask our EMR vendors to do something Ontario-specific. It doesn't do them any good. It doesn't really do us any good in the long run. We really need to establish these global and international pan-Canadian standards in order to ensure that vendors feel comfortable in implementing these so that they can use them everywhere. And that's definitely a big part of eHealth Ontario's job right now, and something we take very seriously.
Okay, that's great. Thank you.
Saw some other hands. Sarah and then Wanda. Oh, and Jason, we'll get to Jason too, who put his hand up first, and I think that's a good.
I had a question that's kind of in the same vein of the previous few questions. Given the complexity of data sharing agreements between organizations currently, and that they, especially in healthcare, they take sometimes years to get signed and agreed upon, how do you think blockchain will change that for the future?
I have this analogy. I grew up, when I went to university, we used to have several guys that shared a kitchen, and it was never clear who was responsible for the kitchen, and the kitchen was unusable. So healthcare data is like that. We're all a little bit confused around who's able to give access or not, and it paralyzes us. So I'm pretty convinced that getting control of that information back to the patient will actually free up much more data much more quickly than in the current paradigm.
And you can actually see in the demo, at least from the patient point of view, which is really the one we'd be probably most concerned about, you can't give them a 40-page agreement. You may be able to give that to an institution like a hospital, but you can't a patient. So it was very important, and you saw in the demo how we ask the patient incrementally for things, only when needed. So a lot of that work is going to go into the UI for the patient, and even the researcher as well, to do those kind of things incrementally so that we're not necessarily talking about the big 100-page agreements all the time.
So follow up. So what does that mean for an organization that wants to be that wants to be a part of the blockchain? How do they join?
How do they join? Well, those are the kind of discussions that we're going to have over the next little while. And that's a good reason why we started this particular project, to start those kinds of discussions. I can't honestly give you an answer today, because one of the biggest issues with blockchain right now is not the technology, it's how do you govern it. And that's something that a lot of discussion is going to happen over the next little while in order to sort that out.
Go to Wanda and then Jason, and you can see some of the questions that are happening online too. Panel can't, sorry, but we'll share them with you.
Thank you for a really good presentation. It's exciting to be here. And you know, as a patient, as someone who works in a hospital, I'm interested. Maybe I'm a bit more selfish, but I'm interested in the path forward for UHN. Where do we go from here? Clearly, the pilot was successful. Are we implementing this for UHN? Are we going to see it immediately, fully implemented?
Well, I think it's going to take us a little bit of time to understand the landscape and who wants to participate. So we've taken an approach to take about 3 or 4 months to share the observations and the learnings across the organization, and to try to understand what does it mean for UHN, what does it mean for the government, and what's the best path forward. I mean, there are many other use cases besides the research conversation that were developed, and we haven't pushed those yet, and they have implications. I think in general, organizations are going to want to have a different way to manage data that's much more patient-oriented. The traditional paradigm of a research hospital having its research information from patients just because they happen to come here, that's not going to be the deal anymore. There has to be a relationship built with the patient and a conversation around access to data, as opposed to we just hold it and that makes us a research hospital. So that whole mindset shift we have to get comfortable with, which I think is very important.
And I like to say that, you know, blockchain is a team sport. And so really it's important to us if we get other collaborators involved. And if it's dinner for one, it's probably not successful. But if we can have a banquet on the blockchain, is maybe a little more exciting. Jason, you've been waiting very patiently.
Great hearing about other people's questions as well. So if I can add to that, I can see this is going to be a very important paradigm shift for both patients and the people who are currently custodians of the data, patient data. What are some of the things that in the Ontario context, maybe in a law policy perspective, that would enable this to be a better conversation, an easier conversation to move from the current paradigm to the new one?
I think one of the things that we need to do is make sure that we don't, put any barriers to this kind of an approach up. I think that's it is a kind of a new paradigm in some ways, although it is supported. There are existing parts of privacy legislation that support this concept. I think we have to give greater clarity on what the patient's rights are, not just to get a copy of their data, but in fact they are the owners of that data, as in a true data economy. They become capitalists of the zeros and ones that they create as a byproduct of their existence. And that whole paradigm has to be thought through. And then you could suggest that maybe people who are insurers should have some terms that let them gain access to that for the greater good. Those are all concepts that can emerge in a very fair way with this kind of fine control of consent to access information.
Thank you.
I'm going to go to a question online, but the question maybe Mike can start with, which is, we hear a lot that maybe this is asking too much of our patients, that, we're supposed to be the custodians of this information, and it's kind of complex, and we can get down to some very granular detail, and maybe not all of our patients want to be involved in deciding which researcher gets access to which blood result. So I wonder, Mike, what your thoughts are in terms of how we could use some of this technology and this approach to make sure that we have fair and equitable access for our patients, or if you have thoughts on that.
First of all, you've designed the app at a level that is quite understandable. The granularity around selection is clear. It's like, it's broad stroke areas that you give access to. Certainly, I didn't find it in any way difficult to determine who I wanted to opt in or opt out of various parts of my healthcare record. So I just don't see that as an issue. And then once you move to this super intriguing marketplace that you've created on the back end in terms of sharing this data, then it just gets more interesting entirely. So I don't see it being an issue at all. I'm just one person though, but I embrace it. I mean, that's the more sources, hence my question about the silos, the more silos that we can connect, the better it's going to be for me. When I offered my GP a login to my 21andMe profile, and they were like totally horrified that I just shared the username and password, it's like, I know we've got some way to go, but to me that's information that in conjunction with a whole lot of other information will help me live longer and be healthier, and why on earth wouldn't I do that? But I think there's still, that can still strike fear into the heart of a lot of people that, sure, there's the downside, someone won't give me insurance, but, when you're my age, I just want to live a long time and have a good life, and anything I can do to make that happen, I'm going to do, right? It's that simple. And the more sources and the more comprehensive picture that can be looked at with regard to my health and my history, I just don't see a downside to that. One of my questions during the trials was, can I connect this to 21andMe? Can I give consent to that type of data to my primary healthcare provider or to a specialist? So, I mean, you're really onto something here. The sky's the limit. The real challenge, you're going to be breaking down the silos and making sure that they're broad enough. But you got that well covered. If this emerging HL7 standard is going to be the one that everyone can rally behind, then we're going to make really fast progress.
I think the key thing is that no one owns the data, so to say. There's no company necessarily. This is a conversation that necessarily owns the blockchain, so to say. This is a question of how that gets built. I mean, how it gets managed, but that I think is very attractive because you don't feel like, which company am I going with now, and what happens if they do something wrong, and how do I deal with that? I mean, do I use am I a Google user or am I a Azure user? I mean, that kind of trust in something that will persist longer, I think, is really interesting. It hasn't got there yet. I mean, companies still help make us do it, but in terms of the Hyperledger fabric, for example. But that idea that there's something that's not owned by a company in managing that information is very powerful.
So I want to thank the panel. Thank you very much for an engaging conversation. I'm sorry to bring this conversation to a close because I feel like we've just got started, but I think that's part of the point, is that we're in the beginning of a very interesting journey that we're going to go through together. I'm very pleased that many of our partners could join us together and to show that this is really a group activity, a collaborative activity. The outpouring of interest that we've had has been intense. want to thank Tracy for stepping up and saying she'd help to manage some of that. I don't think she knew what she was getting into, but you know, that's our way. Come on, it'll be fun, it'll be good. So thank you, and thank you to all of you for being here today to hear a little bit of our journey and our story. So thank you.
What are people doing?